Hi, this is Mrs. Young, and today is our second day on completing the square. And really what we're going to be doing is combining the last 2 days. What we know about the equation of a circle, take completing the square to put our equations into standard form, and then graph the circles like we did 2 days ago. So combining like the last two lessons together into one. This is, I believe, page 46 in your packet, but I'll also attach it separately in Google Classroom, so you might want to have it printed out. But if you don't have a printer, just do these problems in your graphing spiral. But again, you do need graph paper to graph your circles. Here in the first one, you can see that our equation, I guess it's 2a, this equation is not in the standard form of a circle. Remember, the standard form of a circle is x minus h, the quantity squared, plus y minus k, the quantity squared, equals the radius squared. So again, the h and the k are the center of the circle, and r is the radius of your circle. So in this first one, first thing I usually like to do is group my x and y terms together and then push my constant over to the other side. So I want you to rewrite this equation, x squared minus 6x, and we're going to have to add in some number here to complete this square, make it a perfect square trinomial. So that's where we're going to say plus blank. That's that, they call it magic number you're going to add in. Now with our y terms, we have plus y squared plus 4y plus blank, again, some number we're going to add in to complete this square, make it a perfect square trinomial, is equal to, and then when I add the 3 over to the right side, this is 3 plus blank plus blank. Again, these numbers that we add on the left side, we have to also add on the right side. So really, all I did there was add the 3 or the constant over to the other side and then put in my blanks. So now as we go to complete the square, looking at this first trinomial, remember the little formula here is b over 2, the quantity squared. So my b value is -6. -6 divided by 2 is -3, and -3 squared is 9. Since I'm adding 9 on the left side of the equation, I have to add it on the right side as well. In this second portion, or the y part of my equation, I want to complete the square here as well. You can see here that your b value is 4. So 4 divided by 2 is 2. 2 squared is 4. So I'm going to be adding 4 to the left side and right side of that equation. So as we factor completing the, perfect square trinomial, this is going to factor into x minus 3, the quantity squared. Again, notice because of that minus sign, this is a minus sign here. In the next portion, the y portion, we have y plus 2, the quantity squared, right? 2 times 2 is 4, 2y plus 2y is 4y, so that's another perfect square trinomial. Then over there on the right side, if we have 3 plus 9 plus 4, I believe that's 16. So now I know, now that I have my equation in standard form, this is the standard form for the equation of a circle, right? Now we know that the center of our circle is 3, -2. Again, y minus a -2, right? Y minus that y coordinate. And then I know that my radius is 4. When I go to graph this, this is where we're going to go back to 2 days ago. You start by plotting your center. So plot your center at 3, -2. And then the easy points are using your radius. The radius of 4 means from that center point, I can go 4 squares to the right. I can go 4 squares to the left. I can go 4 squares up, and then I can go 4 squares down. And again, we want to try to make our circle from this, right? But I need another point or two on my circle before I can actually graph it. I need more points. So you're going to make a table of values. Again, this goes to our lesson from 2 days ago. What could I plug in for x? Well, I don't want to plug in -1 because I already have a point there. And I don't want to plug in 3 for x because I already have a point there. So something probably between -1 and 3. I could plug in 0, I could plug in 1, or I could plug in 2. Completely your choice. Nothing is wrong here if you plug in 0, 1, or 2, your choice. Let's say, as an example, that I decide to plug in 0. One of the reasons I like to plug in 0 if it works is because 0 is usually an easy one to work with. It's a small number, right? So I'm going to plug in 0 for x into my equation. So I'm going to actually scroll down here a little bit. So as I plug that in, I have 0 minus 3, the quantity squared, plus y plus 2, the quantity squared, equals 16. So as I reduce or simplify this, trying to solve for y, 0 minus 3 is negative 3. Negative 3 squared is 9. So I have 9 plus y plus 2 squared equals 16. You can subtract the 9 over to the right side, right? Subtract 9 from both sides. So you have y plus 2 squared equals 16 minus 9 is 7. Again, you're trying to solve for y. This whole expression is squared. The opposite of squaring is taking the square root, right? So we get y plus 2 equals, and remember this is plus or minus, right? You have two options there, positive or negative. The square root of 7, if you use your calculator, I think it comes out to 2.65. Check for me. I want you to be aware, though, here that you actually have two unique or distinct solutions, two separate equations. You have y plus 2 equals 2.65, or y plus 2 equals negative 2.65. And when you subtract 2 from both sides of each equation, here on the left, you're going to get 2.65 minus 2 is 0.65. Or the one on the right, this other equation, you're going to get negative 2.65 minus 2 is going to give you a negative 4.65. So notice I get two very different values for y. So back to my table. If I plug in 0, I'm either going to get 0.65 for y, or I'm going to get negative 4.65. When I go to graph these or plot these 2 points, 0, 0.65, here's 0, and go up. 0.65 is a little bit more than halfway. And then I also have negative 4.65, so down 4, a little bit more than half. Remember, because a circle is symmetric, right? I have mirror image points on the other side. So notice this is 3 squares to the left of that center line, right? So instead I'm going to go 3 squares to the right, and there's about 0.65 there. Same thing down here, that negative 4.65, 3 squares to the left. Now I'm going 3 squares to the right. And now you have enough points for me that you can go ahead and graph your circle, connect your dots. Again, if you had plugged in 1 or 2 for x, that's fine. You would just have different points plotted on your graph, right? Different points on the circle. There we go. So there's the graph of our circle from our equation. So this lesson is kind of combining the last two lessons. One, can you take an equation of a circle that's not in standard form and put it in standard form? Then can you graph the circle? Find the center, the radius to get your initial 4 points, and then use some more algebra to solve for some other points. So again, we need 8 points total for me, for you to graph the circle. So let's go ahead and try the one right next door. Again, notice that they already pushed the constant over to the other side, right? So they kind of already did that little first step for us. So I'm just going to rewrite it, putting in my blanks. So again, I'm going to have to add something to my x terms, and then I'm going to have to add something to my y terms, and whatever I add, I'm going to have to add on the right side as well. The one thing I wanted to mention is that if you are missing or don't have an x term or a y term, that means that that section you would not have to complete the square on. That's centered at a 0 value, right? That would be a center of 0. So on the first x terms here, again, remember our little formula, b over 2, the quantity squared. So 16 over 2 is 8. 8 squared is 64. So I'm going to add 64 here on the left side, and I'm going to add 64 here on the right side. What the heck was that? And then now with my y terms, again, I've got 12. 12 divided by 2 is 6. 6 squared is 36. So I'm going to add 36 here to my y terms, and then also on the right side. So in this first part, when we complete the square here, we're going to have x plus 8, the quantity squared. Again, that's a perfect square trinomial. Plus, and then with your y terms, this is y plus 6, the quantity squared. And then if we add those big numbers, let's see, 64 and 36 is 100. 100 minus 91. I feel like I did something wrong. No, I think that's 9. That sounds right. That's 9. So there is the equation of my circle in standard form. So now I can tell that my center is at negative 8 negative 6, and that my radius is 3. We're going to go ahead and graph this. So again, first start by plotting your center at negative 8, negative 6. The center is 3. That means I can go 3 squares up, 3 squares down, 3 squares to the right, and 3 squares to the left. Looks like I went off 1 square. That's okay. Next thing I want to do is try to come up with another point on my graph. I have to make a table of values. So what should I plug in for x? Again, look at the points that you have. You don't want to plug in 0, even negative 1, negative 2, negative 3, any of these, because they're not going to be on your circle. You want to either plug in, let's see, negative 5, there's a point, but I would say negative 6 or negative 7. Or number 9, sorry, negative 9 or negative 10. Again, I'm going to pick negative 6, that one right there. But you could pick one of the other ones if you would rather. So if I'm going to go ahead and plug in negative 6 into this equation for x, we're going to have negative 6 plus 8, the quantity squared, plus y plus 6, the quantity squared, equals 9. Negative 6 plus 8 is 2. 2 squared is 4. So that 4, we're going to have to subtract over to the right side. So we have y plus 6, the quantity squared, is equal to, what am I doing wrong? Is equal to, oh, 9 minus 4 is 5. Sorry, guys. And then I'm going to go ahead and take the square root of both sides. So as I do that, I get y plus 6 is equal to, plus or minus, the square root of 5 is about 2.24, again using my calculator. Remember that this is really 2 separate equations or 2 separate solutions. You have y plus 6 equals 2.24, or you have y plus 6 equals negative 2.24. And when you subtract 6 from both sides, you're going to get 2 different solutions, right? You're going to get y is equal to 2.24 minus 6 is, I think, negative 3.76. Check my math. Or on that second equation, negative 2.24 minus 6 is negative 8.24. So notice how we get 2 very unique or different values. So if I plug in negative 6 for x, I'm going to get negative 3.76, or I'm going to get negative 8.24. These are my additional points on the circle. So as I plot those, negative 6, go to the left 6, and then down 3.76. 1, 2, 3.76. It's about 3/4 of the way there. And then I also want to go down 8.24. So I'm going to go down 8.24, about 1/4. And again, plot my mirror image points on the other side using symmetry here. And then I can go ahead, look at, there's my circle. So I can go ahead and connect my points and I'll have the graph of my circle. So again, this lesson is combining, and this is what will be on our assessment, we're combining the equation of the circle, completing the square, and graphing circles. I have an additional problem here. I don't think this was on the original packet sheet, but it's here. Oh, I didn't even write, there's a graph here, but I have to write down an equation for you. So let me go ahead and give you an equation that we can go ahead and try to complete the square on. So write this equation down. 4x squared plus 4y squared minus 16x plus 24y minus 48 equals 0. What's different about this compared to most of the other ones we've done? Well, what's different is that you have a coefficient on your x and y squared values. We know in order to complete the square, we want the a value to be 1. One thing maybe you're noticing too is like, oh, those are the same number. They kind of have to be for a circle. If your coefficients on the x squared and y squared are not the same, you're not going to get a circle, you're going to get an oval. What I could do first though, the nice easiest thing here to do is to get rid of that value. And we can do that by dividing everything by 4, right? Divide everything on both sides of my equation by 4. Also, I'm going to push my constant to the other side. So I'm kind of doing 2 things at once here. Hopefully I'm not messing you up. 4 divided by 4, that's 1x squared, plus 4 divided by 4, that's 1y squared, minus 16 divided by 4, that's 4x, plus 24 divided by 4, that's 6y, is equal to, plus that 48 over 48 divided by 4 is 12. So I kind of did 2 steps there at once, divided everything by 4 and moved my constant over. You might also notice that we haven't grouped our values together. So I'm going to write it one more time, grouping everything together. X squared minus 4x plus blank plus y squared plus 6y plus blank is equal to 12. The first blank, negative 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 on the left side and the right side. For my y terms, I have 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 on the right and left sides of that equation. So now, completing the perfect square trinomials, I've got x minus 2, the quantity squared. Again, it's minus because there's a minus right there. And then with my y's, I have y plus 3, the quantity squared, equals, let's see, we've got 10, 25. So the center of my circle is 2, negative 3, and my radius is 5. What I'd like you to do is pause the video right here. Start graphing the circle for me. Graph your center, your radius, and then make a table of values and figure out what do you want to plug in for x. Come up with your values for y and see how you can graph or plot the rest of the circle. So go ahead and pause the video, graph this, and come up with your additional points. So hopefully you have a circle that's centered at the point 2, negative 3 and has a radius of 5. So you start by plotting your center, plot your radius in all 4 directions, and then you have to make a table of values to come up with another 2 points. I decided, maybe you did too, I decided to plug in 0 so I could get these 2 other points. You could have plugged in 1, you could have plugged in negative 1, could have even plugged in negative 2. That would give you another point on the curve of your circle. What was really nice, and this doesn't happen very often, is when I plugged in 0, I got a nice whole number answer. I got 1 or negative 7 as my y or output values. So I plot 0, 1 and 0, negative 7. Use symmetry to plot those same points on the other side of the circle. And then now you have enough that you can go ahead and graph your circle. Oh, mine's a little sloppy again. Hopefully yours is a little bit neater than mine. Your homework tonight, wow, that is like the worst circle I've ever drawn. Your homework tonight is, that's just bothering me. Your homework tonight is a worksheet that has the same types of problems that I just did. It just doesn't look right, does it? But you have the same types of problems I'm giving you here. There's, I believe, 4 of them for homework. Okay, so clearly I made a mistake when I was solving this, and I was going to re-record the video, but I thought it might help for me to show you that sometimes when you make a mistake, you should go back and double check and find where your error was. Here, when I took 25 minus 4, I don't know why I said 16, it should be 21. The square root of 21 was about 4.58. When I subtract the 3 from it, I should have gotten, again, instead of the 1 and 7, I should have 1.58 or negative 7.58. So I found my mistake, which means I'm going to go back and replot those additional points that I came up with on my graph. So if you have 0, 1.58, again, that's about right there. Here's the symmetric point. And then the other one was 0, negative 7.58, which again would be down here. Now this seems more reasonable when I go to draw my graph. So that's why I just want to mention, like, when you're doing this, if something doesn't look right, if it doesn't come out to be a circle, then clearly you've made a mistake either in your algebra or completing the square or how you solved it. So I just want to show you that, yep, that looks a little better. I'm just not good at drawing circles, guys. But hopefully yours turned out better than mine. So again, your homework tonight is just like this. It's a worksheet with 4 problems where you have to come up with a standard form of the equation of the circle, and then come up with 2 additional points that you can plot with the symmetry points as well. So good luck, and let me know if you have any questions.